Before diving into the details of writing high-quality software, I thought I would spend a few moments just giving some general thoughts and perspectives overall on what's involved in writing software, what it should mean to us as programmers, and how to be prepared, how to get ready to write really good code. And I'll cover three topics in this area. One is stop and smell the roses, appreciate what we've got. Next, I want to spend a few minutes talking about what makes an application successful. I assume you want to succeed just like I do. And what are the basic criteria to make that happen? And finally, taking care of brain and body. So, first, let's stop and smell the roses. Now, can we really call what we do work? And certainly if somebody asks you, what do you do for a living? What do you do for work? You would say, probably like me, computer software. But think about what other people do for a living. They work really hard in machine shops, factories. They cut people open, fix them, and put them back together again. They dig into the earth itself, pulling out raw materials that we use to create our buildings, our cars, everything we consider a part of civilization. Dig ditches, etc., etc. Lots of really hard work, sometimes life-threatening, risky, perhaps very dull. What do we do? Well, we sit around and we think about stuff. Gee, let's see, I think I'll take some data out of a relational table, in fact, 6 different tables, and I'll merge them into a single nested table inside my PL SQL code. But no, wait a minute, I'll do a string index collection. Those are really cool. And then I'll do some transformations and write them here and do this and do that. We pretty much live inside our heads all day long, which can be a pretty scary place to be. But every once in a while, we write stuff down, and then the miracle occurs. They give us money. Think about it. This is a really excellent deal. We just sit around and think about stuff and write it down, and somebody gives us money. Wow. Well, not very many human beings in the entire history of our species have had the luxury of being able to live a life of the mind. And we programmers, we show our gratitude for being able to do this, for being able to do nothing but think about stuff and get paid for it by providing humanity with bug-free, high-quality software, right? That's what we do. Well, maybe not. Actually, I think what we do is we get the job done, but often it's not really pretty. Think about it. Any project you've worked on, you probably entered that project at the start with really high expectations for yourself and everybody on your team. This time we're going to do it right. But as soon as we get into the nitty-gritty of writing the code, our timetables go out the window, and we find ourselves following the quick and dirty pathway, that methodology that we all know and love so well. And we essentially sacrifice code quality to meet our deadlines. Now, this doesn't make any of us feel good, but we don't feel like we've got much of a choice. And the other thing that's just interesting about it is that our users really don't have much of a choice but to use what we give them. Our users are essentially a captive audience. Today, human civilization thrives and depends on software. You can't really imagine life without the internet, without smart products that are built around dozens of chipsets buried inside them. Almost everything has a computer. Almost everything has software inside it. People have to use what we give them. And a lot of times, of course, they end up complaining bitterly about what we give them. Of course, not all the time. We write lots of good software too, but very often, when we follow the quick and dirty path, when we're pressured into writing software to meet deadlines that really don't make a lot of sense, the result are buggy, slow, and incomplete applications. And that kind of software has a real and dramatic impact. People lose productivity. They want to get something done inside their software product, and they can't. They have high levels of stress. The cost to an organization of bad software is also very high. In fact, one study done about 5 years ago in the United States indicated that software bugs cost the US economy something like $60 billion a year. Wow, that's pretty bad. So, of course, we don't like this situation. We don't want to write quick and dirty applications. We want to be successful. We want to roll out really great applications that make our users happy. But first of all, perhaps we should ask ourselves, well, what does that mean? What makes an application successful? I think there are actually 3 main criteria that very simply express whether or not an application is a success. The first one is that it needs to be correct. In other words, the application needs to meet user requirements. It does what the user wants, and especially what the user needs. Now, I imagine that's pretty obvious to you, right? What's the point of writing a piece of software if it doesn't meet user requirements? It would seem very fundamental. Well, that may be true, and that may be something we all acknowledge, but on the other hand, when we look at what we roll out to our customers, it often falls well short of meeting these requirements. So I think highlighting it, making clear that this is a critical aspect is pretty important. Second, the software needs to be obvious. Now, what I mean by this is that anybody should be able to look at a program that I wrote, pick it up, and pretty much understand the purpose of the code, how the code is structured, how to maintain the code. It should be obvious and transparent. The bottom line is that what obvious really means is that the code should be maintainable. Now, maintainability is not something that individual developers like yourself or myself, as we're writing a program, really think about a lot. We're focused in the moment. Get this program to work now. But your managers, your tech leads, should be very concerned about maintainability, because the code you write becomes part of the intellectual property of your company, and it's going to be there for years and years and years. You're going to roll off the project. Somebody else is going to roll on the project a few years from now. They need to be able to open up your program and look at it without having a nervous breakdown. So the code you write needs to be obvious in meaning and purpose. And finally, your application needs to be fast, or at least fast enough. It doesn't do your users or us much good if we write an application that is correct. It does everything that the user wants. It's obvious, it's pretty easy to maintain, but it runs so slowly that the user tears her hair out or takes the screen and throws it out her window. She's so frustrated. So correct, obvious, and fast, I think, sum up very succinctly the key aspects of a successful application. Here's another way that I look at it, just from a graphical standpoint. We need correctness, and I think that's the most important characteristic of a successful application. We need it to be obvious and fast, and the results are high quality code. Now, in a little bit more detail, how do we achieve correctness? Well, first of all, we need to validate the requirements. We need to make sure that what the user is asking us to do actually makes sense and are things that we can do. And one very important point here, I think, to keep in mind is that programmers are very special kinds of people in lots of different ways. But one way in which we're very special is that we use symbolic logic every day of our working lives to get things done. We think about and are very comfortable with logical ways of thought. Now, most people in the world out there, they don't think very logically about things. That's not what they're paid for. That's not how they're trained. And our users in particular may not be trained in thinking very logically. So when you get a document with requirements, and it can look really pretty, nice colors, nice graphs, great font, it doesn't mean that it actually makes sense. It's your responsibility to read those requirements, to uncover logical flaws, contradictions, and gaps, and work with your users to make sure that what they're handing you really makes sense. Next, and very, very important, we need to test our code. If the user says you need to write an application that does X, Y, Z, and we decompose that into 500 different programs to do X and X prime and Y prime, we need to test each of those programs individually to make sure that they meet the requirements. The only way to guarantee that we meet user requirements is to test our code. I think testing has got to be one of the most fundamental aspects of writing high quality code, and it's also one of the scarier parts that we do everything we can to avoid. And finally, another aspect of correctness, code coverage analysis. We need to make sure that the code that we write is actually being run. So those are three aspects of correctness. Let's talk about fast code. There are basically three steps to identifying and writing fast code. One is to identify bottlenecks, find out where in your code the programs run slowly, because most of your code will never participate in a bottleneck and really doesn't have to be optimized. Then analyze the performance, which means, well, how fast is it going? What are the options? What are the different approaches I can take? And finally, optimize that code. Make the necessary changes to make your code faster. And finally, obvious. Well, pretty clearly here, to write code that's maintainable, that everybody can understand, we need to build the code based on standards. So we need a set of coding standards, naming conventions, and so on. But then we need to actually check and make sure that those coding standards were followed. And we do that through code review, either peer code review, having other people look at our code, or automated review, in which we have tools to run against our software and tell us automatically where it finds issues with the software. Now, we're going to look at every one of these aspects across my series of videos as a part of the Practical Best PL/SQL series. But I believe that if you set up your development environment to support these activities, both in general to focus on correctness, obviousness of code, and performance. And if you back it up with these detailed elements, both with your own specific processes and discipline, and with the tools and techniques that I'll be showing you here, I believe that you can produce truly excellent code. And by the way, one of the biggest challenges in pursuing best practice-driven code, and something I hope I can address for you in this series, is that we need to find a way to write high-quality code without sacrificing productivity. As I'm sure you know, there are very few software managers who are enlightened enough or have the room in their schedules to be able to have you say to them, look, I can do it right, but it's going to take me twice the amount of time it takes now. I can write the program in a week, but it'll take 2 weeks, 3 weeks to fully test it, fully make it maintainable, and improve performance. And unfortunately, most managers will not say, okay, take an extra 6 months to finish up the code because we want you to get it right. So what we need to do is come up with ways that allow us to do, in the same amount of time or less time, much, much better and higher quality coding. And that's part of the challenge that I set for myself as I talk to you about these different topics. And my final topic under my general thoughts on software, take care of your brain and body. What do I mean by this? Well, as I mentioned before, we use our brains to do our work. You can't do it without that. I mean, I could write software without hands. I could use different techniques for writing the software, but I certainly need a brain. And the brain is really quite the most amazing machine in the world. It does incredible stuff that we are barely able to comprehend, and certainly can't write software without it. There are two main consequences to keep in mind of the fact that we use our brain to write our code. Number one, our brains live inside our host bodies. Those bodies did not evolve to sit around and stare at screens, and that's why when you spend a lot of time writing software, you end up with back aches, neck aches, wrist aches, carpal tunnel syndrome, all sorts of problems. Our bodies were not made for software. And second of all, human psychology has an enormous impact on how software is written. If we're using our brains to write our code, then all the complexities of being a human being and relating to other human beings actually has an enormous impact on the code that you write. Now, I'm not going to spend a lot of time delving into these issues, but I just want to touch on some high-level points. So regarding the fact that our brains live inside our host bodies, clearly you need to take care of that body. And I think the most important thing here is to drink a lot of water. We spend a lot of time going through the day drinking Diet Coke and caffeinated drinks, tea, coffee, etc. And unfortunately, a lot of those drinks actually further dehydrate us. Very few of us actually drink enough water during the workday. And if you don't drink enough water, it's like having an engine that's not well lubricated. Your brain will not work very well. It'll get sluggish and slow. You'll want to go to sleep. So my suggestion is drink lots and lots of water all day long. And just to kind of verify that it will have a positive impact for you, the next time you come back from some big lunch and you're about to face a status meeting or a code review meeting, you can barely stay awake, don't get a cup of coffee. Get a big glass of water, drink it down, you'll immediately feel more alert, and that alertness will last longer during the day. In addition, exercise, stretch, during your day, get up and stretch, move around, take breaks. Lots of times when you're stuck on a problem, the best thing you can do is simply walk away from your screen, and your answer might spring into your brain when you get away from the depths of the problem that you're facing. So take a lot of breaks, stretch. And finally, in terms of the human psychology, I think it's very important to get things out of your head. As I mentioned before, we spend like pretty much all day, every day, living inside our own heads. And part of the problem there is that if things stay inside our heads, it's really easy to rationalize and conveniently forget things that we know we should do but aren't very interesting to do. And also, we don't like to admit that we don't know things and that we need help. So here are my points. First of all, admit ignorance. If you don't know what somebody is talking about in your application and the technology, ask for clarification. Don't just hide the ignorance and hope to cover it up or discover the information later. You should be working in an environment in which your managers say it's okay to say, I don't know. And let's make sure we get all those things clarified, because ignorance leads directly to bugs. Second, ask for help. This is one of the hardest things I think we have in the world of software, because we're taught by other people that we're supposed to be really smart. We're the geniuses. People are amazed that we write software. And so you're not supposed to ever need help. You should be able to figure it out yourself. And if you're anything like me, you spend hours, even days sometimes, trying to fix a single bug, figure out what's causing it. So here's my suggestion. The next time you're working on a bug for, say, more than 30 minutes, Just stop. Stop. Bang your head against the wall. Don't go for hours. Ask for help. It almost doesn't matter who you ask for help. Ask your grandmother. Ask your sister. Ask your friend. They don't even have to be programmers. Simply by asking for help, your brain will focus intensively on fixing the problem and finding it. And you'll find yourself fixing your problems before they even come over to give you your help. But certainly ask your other programmers to take a look at your code, and that way they know that they can ask you for help, which is great for everybody. Next, write down your ideas and your requirements. In other words, when somebody tells you to write a program to do X, Y, Z, stop and write down all the things you think that program is supposed to do. If you keep it inside your head, it'll be too easy to forget them. And of course, always take your ideas and talk about them with other people, get feedback, because that kind of feedback process can make an enormous difference in clarifying your thinking, getting rid of bugs, and moving through your problems to your solutions much more smoothly. So to summarize, human civilization needs software, and every year the dependency on software gets stronger and stronger and stronger. But human civilization also needs better software than we've been delivering. Now, I'm not saying this to make you feel bad. As I said before, we're getting the job done. People are doing amazing things with the software that you and I have written, but it could be so much better. And I think it's important for programmers to realize that the work that we do has broad and deep impact on the general quality of life of millions of other people. So let's do the best job we possibly can. So we need to ensure that our software is successful, which means that it's correct, it meets user requirements. It's obvious in its meaning and purpose. It's something that people can read, feel comfortable in, and maintain. And it's fast enough to meet user requirements. And as you're about to see, of course, this is not very easy to do. And it will require a careful combination of standards, rules about how to write code, discipline for applying those, and tools and utilities that will help you implement your various standards and best practices. So what we're going to do now in the rest of the videos in this series is look at the key ways that we can meet these different objectives and write code that's correct, obvious, and fast.